Today, we're going to talk about interest. And if you have any kind of bank account, you hopefully get some interest on your bank account. In fact, hopefully you get compound interest, which is an application of the exponential functions we've been talking about in class. Okay, we're going to start with what's called simple interest. We're going to learn why we like compound interest better, but simple interest is relatively simple. We're going to say you had $10,000 given to you by your grandparents when you were born for going to college. We're going to pretend you go to college as a 20-year-old because it's a nice round number. Lots of you will probably go to college at 18 or maybe 19, but we're going to pretend 20 because it's a nice round number. So you've got $10,000 given to you. We're going to pretend like you get a really good interest rate of 5%. Now, what we need to, for a conversion factor, we need to change 5%, our rate, into a decimal. To do that, we move the decimal point from here at the end. I move it over 2 places left. So that gives me 0.05. So I've moved it over 2 places. I'm going to clean that out so it looks nicer. And I've got an R of 0.05. If I want to know how much interest I get each year, I multiply my 10,000 by 0.05, giving me $500. So for leaving my money in the account, the bank paid me $500. That's nice. I like that. So leaving me at the end of the year with 10,500. Take another year, I add another one. So over here, I've got my years. I add another 500 for year 2, giving me 11,000. Year 3, 11,500. If I wanted to get down to year 20, I get 20,000 because I've done 500 times 20, and then I've added my initial 10,000 each time. Okay, so here 500 times 2 plus 10,000. So really what I've got going on here is I've got 10,000 times 0.05. That gave me my 500. I multiply that by my number of years, and then I add 10,000. Or 10,000 times 1. Because of the 10,000 being common here, I've kind of got that going on. So the 10,000 is here. With compound interest, I'm going to take my 5% on the amount of interest I have, or on the amount in my account. I'm going to get rid of this for a second. So my first year, I take 5% of 10,000. I still have the same amount. But my second year, I get interest on this whole $500. So that's 10,500 times 0.05, which is 525. And I've got an extra $25 interest, plus my 10,000 gives me $11,025. Okay. A little bit more money. I'll take it. For my next one, now I'm taking my amount. What I'm doing here is I'm actually just going to multiply by 1.05. And I'll show you why I'm doing that in a second. And that gives me 1157, 76.3. So here what I've got going on is my amount, 10 25 times my 0.05. And that gives me my amount of interest this year. And I added my initial amount. I'm intentionally writing it times 1 because I'm going to basically reverse the distributive property on this. And we call this factoring out. I'm going to factor out the 11,025, giving me a 0.05 plus 1, which is 1.05. So this is my total amount or my initial amount plus my interest. So I've just added my interest rate to 1, and that allows me to get my total amount. Well, that leads us to our compound interest formula. So I probably don't want to have to do this each time individually for 20 years. 1 plus R to the T. P here stands for principal, or the amount we deposited. That's our $10,000. 1 plus my rate is 0.05 to the power of T, or to the time. We're going to do our 20 years. Okay, and that's going to give us, I'm going to use a calculator. I am going to use the parentheses around that. I am choosing to, I actually just typed in 1.05. That gives me $26,533 approximately. I think there's some sense on that. So it's an extra 6,000. This compound interest stuff is kind of nice. Well, we're going to take it further, 40. So we got $10,000 of simple interest here for 20 years. We'd get another 10,000 in the next 20 years. So to get to 40 years, from 20 to 40, that's 20 years, another $10,000 of interest. My compound interest, I do 10,000 times 1.05 to the power of 40 this time, because we're at 40 years. And now I've got 70,000. The longer you leave money in compound interest, the better. It grows much, much faster, because now instead of getting interest on 10,000, at this point, I'm getting interest on more than double. Okay, 5% is a really good interest rate. Right now, my bank account is 0.5%. Part of the reason banks pay you interest is because they use your money to lend it out to other people. So the money I have in a savings account is lent out to somebody, probably for a home. And I've borrowed somebody else's money for my home. And so I have to pay the bank a little higher interest rate that they're giving me, unfortunately, because they need to make money. You also, it's important to have interest, because you've probably heard your grandparents or your parents talk about, this used to only cost this much back in my day. Everything was a lot cheaper. Well, prices are constantly going up. If you're gaining no interest, $1,000 today might be worth about the same as 500 in 20 years. So putting $1,000 in a savings account, or $10,000, will actually be worth less than it is now in 20 years. So it's important to be gaining interest on any money so that it is staying at least equal, hopefully gaining more value than it was at its initial time. Okay, but growth and exponential growth grows very quickly. The simple interest, yes, this keeps up. This probably would keep up with inflation in 40 years, tripling in value, probably. But this is doing a lot better with our compound interest. In fact, it was an extra over $40,000 extra by having compound interest.